So we're going to start off 18.2D by filling in some information we already know. Okay, thank you. I will fix that. There we go. So all of this stuff we should be able to fill out pretty quick. We have 0 radians. What is that in degrees? 0 degrees, right? Our first angle that we have, our 30-degree angle, is what in radians? Pi over 6. The next angle I'm looking in our first quadrant is what? 45 degrees, which is pi over 4. And then our next one in the first quadrant is 60 degrees or pi over 3. And then the last one that's not technically in the first quadrant, but we call it a quadrantal angle, would be 90 degrees, and that's pi over 2. So far, so good? So, if I asked for the sine of 0 degrees or 0 radians, sine we know is y. So if I go to 0 degrees or 0 radians, what is the y value there? 0. Therefore, the sine is 0. Terribly difficult, right? What about the sine of 30 degrees or pi over 6? If I go to pi over 6 or 30 degrees, what's the sine value or the y value? 1/2. What about 45 degrees? What's my sine value? Radical 2 over 2. Sine of 60? Radical 3 over 2. And the sine of 90? 1. My y value is 1. How do I find cosine? Cosine is my x values. So the cosine of 0 is 1. Cosine of 30, radical 3 over 2. Cosine of 45, radical 2 over 2. Cosine of 60, 1/2. Cosine of 90, 0. Pretty darn easy, yeah? Tangent takes a little bit more thinking because tangent is y over x. That's why I ask for sine first, because it's going to be, in this case, it's going to be 0 over 1. What is 0 over 1? 0. In this case, it's going to be 1/2 over radical 3 over 2. Now, we did a little bit of work on that before. Do you remember doing that a little while ago? That's really 1/2 divided by radical 3 over 2. And how do you divide two fractions? Change it to multiplication and flip the second one. Do you remember this? Those cancel, so you have 1 over radical 3. But I can't leave my answer like that, so what do I do? Multiply by radical 3 over radical 3. That gives me 1 times radical 3 is radical 3. And what's radical 3 times radical 3? Radical 9. What is radical 9? So I could just say that that is 3. So what does my tangent end up being? Radical 3 over 3. Okay. What is radical 2 over 2 over radical 2 over 2? Something over itself is... What about radical 3 over 2 over 1/2? Get a clean post-it for that one. Radical 3 over 2 divided by 1/2. That would be radical 3 over 2 times 2 over 1. Those cancel, and I'm left with radical 3 over 1, which I can just call radical 3. And I'll write this in so that you can see where I got it from. Radical 3 over 2 over 1/2. And then this guy, 1 over 0. What is 1 over 0? Undefined. Okay? Now, This is only the first quadrant. But that's really all I need to know. Why? Because in the other quadrants, it's the same stuff. It just might be negative. That's the only difference. How do I remember what's negative in what quadrant? All students take calculus, or all students talk crap. Remember that? Let me go back, find the page. And of course, I don't have it filled out on this one because I took the notes on a different one. But all students talk crap or take calculus. So everything in is positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. Meaning everything else is negative. Okay? So, we can kind of summarize that here. Remember, cosine is x, sine is y, tangent is y over x. In quadrant 1, which is 0 degrees to 90 degrees, that's what this is saying. 0 is less than or equal to theta, is less than or equal to 90 degrees. That means quadrant 1. This is what that looks like in radians, 0 to pi over 2, because pi over 2 is the same thing as 90 degrees. In that quadrant, sine, cosine, and tangent are all positive. Okay? What would I say for quadrant 2? Quadrant 2 goes from 90 degrees to what? Where does quadrant 2 end? 180. So if I wrote that in radians, I know 90 degrees is pi over 2, because that's the end of quadrant 1, to what is 180 in radians? Pi. So in quadrant 2, what is positive? S, right? That's the quadrant, that's the S quadrant. So sine is positive, everything else is negative. Quadrant 3 goes from 180 to what? 270. In radians, that would be pi to what? 3 pi over 2. And in that quadrant, what is positive? Tangent. Everything else is negative. And then finally, quadrant 4 is from 270 to 360. In radians, that's 3 pi over 2 to what? 2 pi. And what is positive in quadrant 4? Cosine. Everything else is negative. So again, that's that all students, there's your S, take, there's your T, calculus. Can't even spell it. Calculus. ASTC. Okay, so far so good? Okay, so let's talk about some things. If I said that this is the angle I'm talking about, 15 pi over 4, I want to know what quadrant the terminal side is in. I want to know what the reference angle is. I want to know what the sine of theta is, the cosine of theta is, and the tangent of theta. Okay? So, 15 pi over 4. Now, we did this where I counted by pi over 4s, right? Do you remember that? So this was 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, right? 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. What am I trying to get to? 15. So 9, 10, 11, 12, 13, 14, 15 pi over 4 is coterminal with 7 pi over 4. Do you understand where I got that from? Let me go back. Where is the day that this one? Do you remember when I highlighted all the 45-degree angles? That's what I'm doing because pi over 4 is 45 degrees. So I was just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's how I ended up there. I'm following those colors. So this angle is coterminal with 7 pi over 4. In other words, if I were to draw this, there's my terminal side. We went one full revolution and then another roundabout like that. What is the reference angle? 45 degrees, but since it's in radians, I have to say the reference angle is pi over 4. Now, we did a worksheet the other day called Patterns in the Unit Circle. Do you remember that worksheet? And on that worksheet, I'm hoping that you recognized that all of the angles that had a denominator of 4 ended up with a reference angle of pi over 4. And all angles that had a denominator of 6 ended up with a reference angle of pi over 6. Mind blown right there. All angles that have a denominator of 2 have a reference angle of pi over 2. All angles that have a denominator of 3 have a reference angle of pi over 3. Sorry, I was thinking there. Pi over 3. So we're always going to be referring back to one of these guys right here, that first quadrant. So my quadrant is quadrant 4, right? And what do I know about quadrant 4? I know that in quadrant 4, cosine is the only thing that is positive. Therefore, my sine value is negative and my tangent value is negative. Does that make sense? Because that's what's true in quadrant 4. From there, I already identified my reference angle is pi over 4. And I can come over here to pi over 4. And guess what? All of this information is the same for this angle. The only difference is sine and tangent are negative. So the sine is going to be negative radical 2 over 2. The cosine is positive radical 2 over 2. And the tangent is negative 1. So once I identify the reference angle, that tells me which piece of information I use. I just need to remember to throw in the appropriate negative signs. Does that make sense? And that works for all angles, whether they are in the unit circle or more than one revolution, meaning outside the unit circle. Identify the reference angle, and you can find everything you need to know. Kind of make sense? Yes?
Wait, where does on sine 0 and sine, it says negative the square root of 2 over 2. Where did the negative come from?
Where did the negative come from? The negative came from the fact that this angle is actually in quadrant 4. So even though it uses this stuff from its reference angle, I have to remember that in quadrant 4, cosine is positive, sine is negative, tangent is negative. So I put those in there. Okay? So let's think about this guy. Negative 5 pi over 6. What do you think my reference angle is going to be? Pi over 6. So if my reference angle is pi over 6 and I'm going negative 5 pi over 6. Let me use the other chart because that seemed to make more sense. I'm going to be counting by pi over 6's, which is every 30 degrees. Yeah? So let's see. And I have to go 5 in the negative direction. So that's 1, 2, 3, 4, 5. So that's where we're at. Does that make sense? I don't know why I'm off the screen there. So I'm coterminal with what? 7 pi over 6? So if I come over here, this angle looks like that. Coterminal with 7 pi over 6. What quadrant is that in? Quadrant 3. What do I know about quadrant 3? Cosine is negative, sine is negative, tangent is positive. What do I do from there? I look up pi over 6 on my chart here. Sine is radical 3 over 2. Because it's in quadrant 3, it's negative radical 3 over 2. Cosine is 1/2. Since it's in quadrant 3, I'm going to say it's negative 1/2. And the tangent is radical 3, and that is positive in quadrant 3. What did I pulled the wrong one, didn't I? I keep going back and forth on those. Sorry. That makes... Let me get my trusty white out here. Keeping my negative signs because those are all still the same. Come on. All right, we'll make that look better. So let's see. Sine is negative 1/2. Cosine is negative radical 3 over 2. And tangent is positive radical 3 over 3. So I don't have to keep calculating that tangent thing. I just need to do it once, and then everything else can refer back to that. Does that make sense? All right, let's do these guys. 11 pi over 2. The denominator is 2, so what's the reference angle? Pi over 2. Now, that one's kind of funny because remember I said reference angles are always acute? Pi over 2 isn't technically acute. It's 90 degrees. It's a right angle. But it's going to use the pi over 2 information just like a reference angle. All right? What quadrant is it in? It's not really in a quadrant because it's on the axis. So let's think about that. 11 pi over 2. Well, let me go back to my colored one here. That means I'm going every 90 degrees. So here we go, starting at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what do we have? It's going to be coterminal with 270 degrees. In other words, the terminal side is the negative part of the y-axis. Do you get that? So when it says quadrant, I'm going to say negative y-axis. If it was going up, I would say positive y-axis. Does that make sense? Okay, so now let's look at that. Pi over 2, let's see, 270. That's kind of sort of not on my chart, right? So I'm going to think about it in terms of 90 degrees, in that my sine is 1, my cosine is 0, and my tangent is undefined. But let's think about the signs of those, because the signs aren't really included in my chart. Sorry, wrong thing there. So if I'm thinking of 270 degrees, right there, what are the coordinates that go along with 270? Isn't it 0, negative 1? Mm-hmm. So what's negative? My sine value, right? Cosine is 0, doesn't really matter, positive or negative. And tangent would be negative 1 over 0, which is undefined. So those quadrantal ones, you really do need to think about positive or negative, kind of based on these guys. Thinking of which is positive and which is negative from the 0 and the 1. Kind of makes sense? All right, you take a minute and you try these guys. These ones are in degrees, so you can give the reference angle in degrees, but come up with the quadrant, the reference angle, and then the sine, cosine, tangent from that. So you take a minute and do those 2-degree ones. Then we'll do the problem on the back. Okay, so I'm going to start off with 765 degrees. So let's see. I have a feeling, my gut tells me that since the last digit is a 5, and only one of these has a last digit of a 5, I have a feeling the reference angle is going to be 45 degrees. But I do want to verify just because I'm particular like that. So I know that 1 revolution is 360. What's 2 revolutions? 720, right? What would be another quadrant past that? It'd be 90 degrees past this, right? 810. I'm not there though, am I? So that means my terminal side is somewhere in here. So from 720 to 765, what is that angle? Is it 45? 720 plus 45 is 765. So I was right. The reference angle is 45 degrees. What quadrant is that in? 1. And what do we know about the signs in quadrant 1? They are all positive. So I go to my 45 degrees up at the top. The sine is radical 2 over 2. The cosine is radical 2 over 2. The tangent is 1. And I don't need to worry about any signs. Easy peasy? Okay, negative 150. Well, I know that negative 180 would be all the way over to here, right? And I don't want to go that far. I want to stop just before it. That's my negative 150. So where's my reference angle? My reference angle is right there. So if that's 150 and that's 180, both negative, what's my reference angle? 30 degrees. That is in quadrant 3. Oops, 3. And what do I know about quadrant 3? Tangent's the only thing that's positive. So sine and cosine are both negative. Pulling out my information from 30 degrees, sine is 1/2. Cosine is radical 3 over 2. Both of those being negative in this quadrant. And the tangent is radical 3 over 3. Easy peasy? Okay, you ready for the last problem on the back? There's one problem on the back, and it's slightly different than those guys. Say what? So here's an angle. Hang on. Okay, so this is an angle. Is it a positive or a negative angle? Negative angle. We don't really care about the measure of the angle. We want to find the sine, the cosine, and the tangent. So here's the deal. This angle makes a triangle. If this is my positive x-axis and this is the terminal side, that's the angle, correct? I would say that is theta right there. Do you get that? I just kind of took that angle and redrew it down here. Yeah? Now, this point is important because what I'm going to do is I'm going to make a right triangle right here. Just like we had all these guys, we made our right triangles. I'm looking at something in the 4th quadrant, so I'm going to make that right angle right here at the x-axis. Here's my right angle right at the x-axis. And if they're telling me the x value is radical 11, they're telling me this side of the triangle is radical 11. Right? Because that's the part that's directly on the x-axis. They're telling me the y value is negative 5. Now, I have a little bit of an issue because if I'm labeling the side of a triangle, I have to call it 5, not negative 5, because I can't have a negative length. Why do they call it negative 5? Well, because it's in quadrant 4, and in quadrant 4, cosine is positive, but sine and tangent are both negative. And negative 5 is the sine value, technically, right? Well, it might not exactly be. I need to find the hypotenuse here. Because when it asks for sine, cosine, and tangent, I'm using straight up SOHCAHTOA. So how can I find the hypotenuse there? It's a right triangle. Can I use Pythagorean theorem? Okay. So if I use Pythagorean theorem, radical 11 squared plus 5 squared is equal to my hypotenuse squared. What is radical 11 squared? 11. 5 squared is, so I have 36 equals c squared. What does c equal? 6, because I have to square root, right? So now, let's find the sine value. remembering my SOHCAHTOA. Sine will be opposite over hypotenuse, so what is that? 5/6. But I have a negative sign because we're talking about a fourth quadrant angle. Is this making sense to you? Is anyone bothered by the fact that the hypotenuse is not 1? This is not a unit circle, clearly. Okay? But we still can find the sine, cosine, and tangent as long as we have a point. Cosine is adjacent over hypotenuse. Radical 11/6. Yeah? And tangent would be opposite over adjacent. I'm going to write that down here because I have a little simplifying to do. Because I can't leave radical 11 on the bottom. What do I have to do with it? Multiply by radical 11 over radical 11. What does that give me? 5 radical 11 over 11. That's what the tangent is. So 5 rad 11 over 11, and again it's negative because we are talking about a fourth quadrant angle. So all of them are done the same, except when you get one like this, you have to do a triangle. Okay, not too bad. Happy studying.